Thanks for the introduction. My name is Manuel, and I'm a postdoctoral researcher at University of Bern in Switzerland. And today I will present our paper, Automated Generation of Code Contracts. And the question is Generative AI to the rescue. So first, shortly, let us recall what design by contract actually is. So let's imagine we are a component developer and we want to provide a component to a system integrator as our client, and at some point something doesn't work and fit together. And now the question is, what is the problem here and who is to blame for that problem? So contracts can help us to answer that question. Let's say we have a client, and the client here have to pose a valid request to our service that we provide, and we can call that a precondition. Moreover, then we, as the provider of the service, have to guarantee that service, that it works correctly, and we can call that a postcondition. Moreover, in design by contract, we also have class invariance. So that just means that in object-oriented program, our class or our object particular, the fields have to be always in a valid state, and we can assign invariance on that. So what happens if something went wrong, and if particularly the client will violate the contract by raising a bad request to the provided service? And then we can say, okay, this here's the contract, and say, okay, no, we don't handle that request, and we just raise an exception. So now we can answer that question. If a precondition is violated, then the client is to blame for the problem. And if an invariant or postcondition is violated, then the provider is to blame for that. All right, sounds good. So how can we implement that in practice? Particularly, we had a look at Java. And here we have a small example of a stack, and there's these typical operations, pop and push. And there is a specific extension to Java called the Java Modeling Language, or JML for short, and that we can use to add annotations to our Java source code. For example, we have here a precondition that is annotated with this require keyword, and it tells us that the pop method should only be called if the stack is not empty. Or as another example of a postcondition, we can write an ensures annotation and say, okay, if we push something to the stack, an item, then afterwards the stack should not be empty, obviously, and the element that we just pushed and assigned to that method should be on top of the stack. Okay, but how is this now used in practice? So in reality, there are some studies on that, and it shows that there's not much of an adoption there, and the reasons for that are manifold. So just to name a few here, there may be still a lack in tooling and integration into the development environments. There is maybe missing even training, that the developers don't know how to apply that in the practice. And moreover, and one of the biggest problem, let's say, is that this is kind of an additional burden to the developer. It's kind of similar as to like code documentation, where you still have to write your code, and then in addition you have to write these kind of documentations in terms of contracts. And so there are already some ideas on how maybe to overcome this kind of burdens. And so we can basically distinguish between so-called static methods and dynamic methods here. And these are intended to automatically generate such contracts. So for static methods, they just take the source code, parse it, analyze it, and then can typically provide at least simple kind of contracts. There's some little bit more advanced techniques, but for such we have to give, for example, natural language specification, and then they can, in addition, analyze these to generate some more contracts. For these dynamic methods, we need a program, and that program have to be executed, and also we need a good test suite with lots of unit tests, and these unit tests then are recorded and traced, and from these traces we can then derive, based on some patterns, in a dynamic way, our contracts. So we have here a little bit of a problem. So either we have very simple properties, or we have to have some upfront investment such that we have to provide these auxiliary artifacts or unit tests. And they must be available at this point to generate these contracts. So we thought, okay, maybe we can even lower that burdens a little bit more. And the idea here was to take these new fancy generative AI approaches and say, okay, maybe we can use them to generate contracts. The idea here is very simple. So we take our source code, in this case just a Java file, put it into the AI, and the idea is to output the AI should output and generate it as a text file, in addition with the generated annotations. And to point out here, what we did is kind of an explorative study. So we wanted to just understand, so what is the potential of this generative AIs to support design by contract? And as a researcher, I want to understand how we can assess actually the quality of these contracts. And yeah, so this whole work actually started as a master thesis, and the first question here was, okay, what kind of model can we use to do this task? And we decided for a relatively small model. We choose this CodeT5 family. In particular, here I will pretty much talk about CodeT5 Plus. And this is an open source model that was released in the beginning of 2023. It's a large language model, as you know, like from ChatGPT and so on. And as I said, it's a relatively small model with around 200 million parameters. Compared to like nowadays, we already have even open source models that are exceeding these 100 billion parameters. And this model, good to play around with. It has already is already trained on some code-related tasks. So, for example, code summarization and code completion and so on. So we thought, okay, that may be a good choice. One problem here is it's not fine-tuned for so-called instruction following. That means we cannot just, like in ChatGPT, ask it questions in natural language. So we have to train it on a specific task, here the generation of contracts. Also important for some of our design decisions, it has a relatively small input window, which means we can just input around 512 tokens, which is around 300 to 400 words. So based on this, we had said, okay, we have to boil down this task a little bit. And we say, okay, just take not the whole class file or the whole project, but just take the method and the method declaration and its body, put it into the model, and then generate the contracts. And in the end, we then automate just the reintegration of these contracts into the whole source code. And as I mentioned, we have to train the model on the task. So that means we need a data set for that. And as there is no actual data set available for especially these JML annotations, we had to first created one ourselves. Therefore, we used the search engine, and we found actually around seven different repositories with around 40,000 Java methods. So these makes up, if you split them up and split them into the contract and the source code, make up these 40,000 K pairs. As each contract can has multiple annotations in terms of postconditions and preconditions, it has around 30,000 JML annotations. So the first question that we asked was, how suitable is our data set now to really train such a model? And what we did is kind of a, let's say, standard method that we applied. It's a so-called 5-fold cross-validation. So what you do is you take your data set, you split it into 5 equally sized folds, and then you take out one of them, train the model on the remaining, in this case, 80% of the data set, compute the score on the remaining 20 ones, and then you repeat this 5 times for every fold. In the end, you average up your scores, and then you have kind of an estimation how well your model performs on that data set. And the scores that we computed are typical text similarity metrics. So the first one that we had a look at was the so-called exact match that just simply checks a 1 or 0 for if the match is exactly textual equal to what is expected or not. So actually we got a relatively good result here with about 60% of exact match. And there are some other ones, just to mention one here, that we also applied is the so-called blue translation score. So that is something that's also used to score translations of humans. So you would say if you have a translation score of around 0.7, you're a professional translator. And if it's over 0.3, then it's kind of understandable. And our model ended up in the middle with around 0.5, which you can say it's a kind of good and fluent translator from Java source code to contracts. So, however, these metrics are only of limited value to us. So, to really understand the quality of the generated code contracts, we want to have a closer look into their quality. As we know, like typically in programming, there is not only one solution to code something. So the second question that we ask here is how well-formed are our code contracts that are generated by the LLM, and therefore we did a syntactic analysis, and we took therefore some more projects that are actually not included in our dataset. Some of them are coming from our courses where we also teach design by contract. Some of them, maybe you know the defects for J benchmark. And then we generated our contracts on them and checked if we put them into the compiler, if they compile. And we saw that from these over 5,000 ones, we had around 5% of annotations which produce compilation errors. So now the next question is, what is the problem here with these compilation errors? And therefore we did a manual error classification for all of the errors in the academic sample and for half of the errors in the defects for J sample. So the first things that we saw were very simple mistakes, like that the model just omits some kind of semicolons or closing brackets in the end. Maybe something that can also be fixed easily. Some other things that we saw are kind of, let's say, out of scope of what the model did. So for example, if you access a private field in JML, you have to actively annotate it as so-called public. But the model, as I told you, is just seeing the method and the method body, and it doesn't actually see the field or can do anything with that. A similar problem we saw for inheritance. If you use a method that is in a subclass and it's overriding another method, then you start your annotations with this also keyword. Similar problem here. The model just sees the method, but it doesn't know that it's within an inheritance relationship. Yeah, but especially the last ones and probably also the first ones are relatively easy to fix. The last ones are also kind of unambiguous quick fixes. Maybe more interesting here are some semantics mistakes that we saw. For example, we saw some symbol hallucination in our tic-tac-toe game here that is used to introduce design by contract. There is a method that checks if the game is not over. And therefore, we check whether squares left in the game must be greater 0. And then the model assumes, maybe if there's squares left, there should be squares right. But that's actually not the case. Some other things that we saw are comparing of incompatible types. For example, comparing a Boolean result to a fixed string, or similar problem like just comparing the void type to something else. So, to get even a better understanding of the quality of the code contract, we next did a logical analysis of these, and therefore we specifically had a look into our academic examples. And as I said, we use also them to introduce the design by contract, and therefore we know or have a very good understanding of what the contracts are in this context, and which means we have a reference contract to which we can compare our generated ones. And the first thing that we saw, if we compare them, that around 16% are actually equal in the sense that they are logically equivalent, and some of them are kind of weaker. So if you compare them, you find, there's maybe something missing that is referenced in the reference contract. Remarkable, there's actually over 50% are stronger than our reference contracts that we handcrafted. So there's something added to the generated contract. And we also checked whether these additions that the model made are valid in the sense that they do not forbid intended behavior. But for 14% we had such problems where actually the model added something but it forbids these intended behaviors. Also 9% seem kind of unrelated to the reference contract, so there's something in there that is not mentioned in the reference. And we also checked them, and for all of these 9% that we saw here, they are invalid in the sense that they forbid intended behavior. So What means, okay, yeah, we have some already good results in the sense that the model can generate contracts that are actually more detailed than the ones we handcrafted. However, if we would use it as it is, we would still have to manually check that. To give you some ideas, what we saw in our qualitative analysis for the tic-tac-toe game, for example, we saw also some non-trivial things like range checks on the board, if you get such a row, for example. Or also we saw some kind of trivial conditions, for example, that just generated requires true. Although that's maybe something which we can check on a little bit closer, because as I recently learned, some of these tools actually use this as a kind of convention to say there is no precondition for this method, which would actually be a non-trivial conclusion. In some cases, we also just simply saw that it copies the return statement, and in JML there's this special syntax, this /result, and it just compares them, which doesn't make much of a sense or is much helpful in the first place. In defense of the model, we could say, yeah, maybe it could be a kind of regression testing. If I later on, for example, refactor the return, then I could check if it's still valid here. For the stack implementation, we saw that it also does this kind of size checking for the pop method. For some reason, it doesn't generate the size check for the top method. And for the push method, we did not found the checking that the element after pushing is on top of the stack. Okay, after answering these questions, let's talk about threats to validity. For our data set, we checked some random samples there, but I think it's also be good to have a better understanding of that in terms of the quality of our data set, because we know for fine-tuning a model, it's very important that we have a very good data set. And also something that could have been happened also by the research question 1 and their results, it kind of indicates that the model probably have already seen some kind of JML annotations. Also to mention here that these academic projects that we had to look at have not been seen by the model in the pre-training, and also these defects for J ones, they don't have any contracts. So for research question 1, these metrics that we computed are maybe not the best choice for code, so maybe that's also something where you should not interpret too much into these metrics. And for research question 3, our logical validity, of course, is just related to the reference contract that we look at, so it's not an absolute value that we computed there. Also in terms of threats to external validity, we just had a look into Java and JML, so we still would have to check whether our method generalizes to other programming languages and other frameworks that also have possibilities to use design by contract. And something to be mentioned about our data set is that if you look how we pulled out these contracts from different repositories, we saw that 2/3 of our JML annotations are actually coming from a single project. So there's this question whether it's kind of biasing our fine-tuning and the outcoming results. What we did is we excluded that project from fine-tuning and redone all this 5-fold cross-validation. We saw that there's only a decrease of 10% in our blue score. So probably it's not that much of a problem here. For research question 3, also our error classification, of course, we just had to look at some samples. Also, there's still some more that we could have a look at, so this can still be incomplete. In summary, like we saw that our model can generate contracts of high correctness and completeness, so that over 95% of these annotations actually compile. And even in our small case study, we saw that over 50% of them were stronger than the reference contract. So we also saw that it still makes syntactic and semantic mistakes. So if you use it as it is, you would still have to manually verify the contract itself. In conclusion, so design by contract, that's also what we saw on the data set that we've found. It's already 40,000 methods, but it still tells us that design by contract is not widely applied in Java. Although this dataset is available and it's now possible also to train additional and other models with that, and to come back to our original question, generative AI to the rescue. So yes, we saw that there's some potential to increase adoption of code contracts in practice, especially because this method does not depend on any dynamic analysis, or you don't need to provide auxiliary data upfront. Of course, there's still work to do, like, for example, post-processing the outcome and by quick fixing those kind of frequent errors. Also, it might be interesting to have a look at larger models, such that we have ones with a greater context window to provide more context information instead of just the method itself. And hopefully this may then reduce this kind of hallucination problems. And as already mentioned, there are other languages with also frameworks for design by contract. So I think it could be helpful to also look at them, see how that generalizes. Maybe there's also some positive effect in terms of kind of transfer learning between these languages. And yeah, with that, I want to close here, and I'm happy to take your questions.
So thank you, Manuel, for the nice talk. Any questions?
Thank you. Interesting. Do you have any ideas to improve the performance of this system? Because I understood that you simply use existing AI, although you did some fine-tuning. But do you have any other ideas to improve the accuracy of the output by the AI system?
So you mean that, for example, I mean, as I mentioned, we could like, in the best case, you would simply have a larger data set to increase the accuracy. That's a typical solution in these problems. So what could be a thing to be used is that you start, for example, with these dynamic or static methods and generate contracts, and then try to have a larger data set and maybe then train the model on that. That could be maybe a solution to get more training data for that. And of course, maybe also for us, it was just a basic thing of like, let's say, have a look at this single model. So there are more models outside there, and even better ones today than a year before. So looking at different kinds of models and maybe a little bit different architecture, so could also help to increase that.
Thank you.
Okay, any other questions? We have plenty of time.
Yeah, nice presentation, thank you. I was wondering, how deterministic are the generated results?
Sorry, I didn't get the last part.
How deterministic are the generated results?
Yeah, that's an interesting question. We actually did not check on how this is also called this output variability, if you just retrain it and then it changes. The problem here is that most of the things that we analyzed are kind of manual thing, that you have really to go yourself into the code and check these contracts. But that's a bit hard then to do it even multiple times. But that's definitely a thing what we should check for future work for how the results change if you just multiple times apply them. But yes, they technically can change.
Any other questions? Yeah.
I was also wondering, normally most people write comments and then generate code out of that. How feasible do you think it is to write these contracts and then generate code based off these contracts? So do it the other way around.
You mean that you write first a comment and then just for how
so basically only write these contracts and based off these contracts generate the code?
I guess probably more difficult. I mean, yes, it's called design by contract, so the very original idea is actually to write these contracts first. But that would be interesting. But yeah, I think it's even more difficult than the other way around.
Yeah, I think so. Thank you.
Thanks for the talk. I think it's not working. So, I just speak up. So in the beginning you talked about inference and also class invariance. So did you also look into those in the data set? Like whether also class invariants, and are they harder to generate? Because I could imagine, like, if you have a larger class, inferring these class invariants could be harder.
No, we didn't. So the way that we search through the query and how we queried the search engines, we just search for these pre and post conditions actually. So that's what we don't know yet. Like, technically, of course, you could emulate such invariants with just adding pre and post conditions, in the sense to make always sure that whenever you call any method that it's holds up to these invariants. But probably it's not the most efficient way on how to design them, right?
Okay, any other questions? We have more time. Also, any junior members welcome, or the first time at GPCE? So maybe a question for me. On your data set, you said there was a data set available, so you created your own. So how did you ensure that the annotations you made are actually correct, like the right ones for the methods you found? Also, results suggest that some of your annotations were too weak, right? So the language model actually found better annotations, like stronger annotations for some of them.
Yeah, I think there we have to differentiate between what we pulled out as a data set and the analysis that we did later on. So as I said, for the data set, we just checked random samples, whether they look fine. And for most, what we found out in the wild, let's say, looks like good contracts, that they are well maintained for those who did this on their project. But yeah, of course, it would be more interesting to really check that over the whole data set in the best way, in a kind of automated way. And yeah, the other thing is like the things that where we checked, like, for example, that this contract is weaker. That is something where we compared it to the contract that we handcrafted manually for our academic projects, which we used to introduce design by contract also to students in courses in the university. And yes, that's something that evolved over like the last 10 years, these contracts for these projects. So we assume that we already have, at least from a developer's point of view, a good understanding of these contracts in our simple stack and simple tic-tac-toe example. That is the assumption. Yeah.
Yeah, thank you. And is your data set available online? Can we use it?
Yeah, the data set is available in the replication package. You find also the link in the paper. And there you find also all these, the scripts that we use to train the model, and also the final models if you want to play around with them. As I said, CodeT5 is a relatively small model. So if you just want to generate a contract for a few methods, I could even run that on my local CPU here on the laptop.
Yeah, very cool.
Did you see any interesting behavior of the LLM when you look at the output of the LLM? For example, well, CodeT5 may be good at generating contracts in some particular style of a program or method, or it is very bad at some, maybe it's complex method. Did you see any? Did you observe such a behavior, interesting behavior?
You mean that the quality depends on the style, how the code is written?
Yeah, for example.
Yeah, we don't know actually yet. Yeah, I mean, the ones that we had to look at are from these defects for J benchmark. These are pretty well maintained projects that are used also for various kinds of benchmarks in the software engineering field. So we assume that these have a high quality of code writing. If the writing is, the code is bad, yeah, maybe that could influence. It would be interesting to see if this influences the model's quality.
Okay.
So we have time for further questions. So if there aren't any, then I would say let's thank the speaker again.